Welcome to Understand the Math. In this video, I'm going to teach you how to find the inverse of a function algebraically. I'll go over 4 steps that you can easily follow to find an inverse, and then walk through these 4 example problems so that you'll know exactly what to do. Let's get started. I'm going to begin by going over the 4 steps that you can follow to find the inverse of any function algebraically. If you're given a function f of x, you can follow these steps to find the inverse of a function that's written as f inverse of x. Here's the 4 steps. The first step is that you're going to replace f of x with y. You're then going to switch x and y. You'll then solve for y. That takes most of the time. And then the last step is that you just replace y with f inverse of x. Let's look at our first example problem. We're given f of x, and we want to find the inverse function of f. I went ahead and rewrote our steps on our right-hand side so that we can easily follow them. Let's begin with the first step that tells us to replace f of x with y. So instead of f of x, we're just going to write y is equal to 2x plus 3. Then our next step tells us that we are going to switch x and y. So wherever we have a y, we're going to write x, and wherever we have an x, we're going to write a y. Our third step tells us to solve for y. When I look at this equation and I want to solve for y, I think it's easiest if we switch sides and make the y on the left. So let's just write this as 2y plus 3 is equal to x, and then now we just solve for y. So let's go ahead and let's subtract 3 from both sides. So we have 2y is equal to x minus 3. And then let's divide both sides by 2, and we get y is equal to x minus 3, all divided by 2. And then our last step is just to rewrite y as f inverse of x, and that'll give us our answer. So we have f inverse of x is equal to x minus 3 divided by 2. And that's our final answer. Before we go on to our next example, I want to show you something. If we go back to step 1 and look at our original function tells us that we're going to start with x, which is our input, and we're going to multiply by 2. And then we're going to add 3. Now let's go ahead and let's look at f inverse of x. What does this tell us to do? It says we're going to start with our input, which is x, and we're going to subtract 3. And then we're going to divide by 2. Now let's compare these two. Our inverse function just undoes what our original function does. So instead of adding 3, we subtract 3, and then instead of multiplying by 2, we divide by 2. So it undoes the action of the function in reverse order. Now let's go ahead and let's look at our next example. Our second example is a cubic function. We're going to follow the same steps, and I've again written them here on the right-hand side to make things easier. Our first step is to replace f of x with y. So we write this as y is equal to 2x cubed minus 5. Our second step is to interchange or switch x and y. So y becomes x, and then our x becomes a y, just like that. Our third step, that's the hard part. That's when we have to solve for y. Let's go ahead and let's look at this, and then let's switch the sides. So I have our y's on the left-hand side. This becomes then 2y cubed minus 5 is equal to x. Now we're going to solve for y. Let's first add 5 to both sides. So we have 2y cubed is equal to x plus 5. And then now let's divide each side by 2. So we have y cubed is equal to x plus 5 divided by 2. And then our final step is we need to get rid of the cube. So if we take the cube root of y cubed, that'll just get y. So on our left, we're going to get y, and on the right, we have our cube root function, x plus 5 over 2. And then our last step, we'll put it over here, is to just replace y with f inverse of x. This gives us f inverse of x is equal to the cube root of x plus 5 divided by 2. Now let's just look at the order of operations and compare our function and our inverse function. If we go back up to step 1, we can see that we started out by cubing our function, and then we multiplied it by 2. And then we subtracted 5. Now for our inverse function, we need to undo these operations in reverse order. So notice for this function, what did we do first? We added 5. That undoes the subtracting 5. And then we divided by 2. That undoes our multiplication. And then lastly, we took the cube root, which undoes cubing the function. Let's now look at our third example. In this example, we have the square root of a function. Let's begin by replacing f of x with y. So we have y is equal to the square root of 8x plus 5. Our second step is we're going to switch x and y. So we have x is the square root of 8y plus 5. Now, this is where it's really important. Before we go on, we have to make a note of one thing. Notice that x is a square root. So what we need to do is make a note of that, and we're going to say that x, because it's a square root, has to be greater than or equal to 0, because a square root is not negative. Now let's go ahead and let's go on to our third step. Our third step says that we need to solve for y. So let's go ahead and let's reverse our terms. We're going to put our square root of 8y plus 5 on our left and our x on the right. Now to solve for our y, we're going to have to square both sides of the equation to get rid of our square root. So we have the square root of 8y plus 5 squared is equal to x squared. So that gives us 8y plus 5 is equal to x squared. That was why it was so important that we went ahead and noted that x had to be positive, because we just got rid of our square root and we would have forgotten about that fact. Now let's keep going. We're going to solve for y. So I'm going to pull the 5 to the right-hand side. So we'll subtract 5 from both sides. So we have 8y is equal to x squared minus 5. And then our last step is we're going to divide by 8. So we have y is x squared minus 5, all divided by 8. And then our fourth step, we're just going to rewrite y as f inverse of x. So we end up with f inverse of x is equal to x squared minus 5, all divided by 8. And that's our final answer. And then the only thing we have to add is this restriction, which we highlighted up here. So let's go ahead and add that. And we're going to have to remind ourselves that x has to be greater than or equal to 0. So just remember to do this step if you're working with a function that is a square root. Let's now look at our last example. This example is an example of a rational function where we have x in our numerator and in our denominator. Our first step is we're going to replace f of x with y. So we're going to write down that y is equal to 2x plus 1, all divided by 3x minus 4. In our second step, we're going to switch x and y. So this is x is equal to 2y plus 1, all divided by 3y minus 4. In step 3, we're going to solve for y. So let's go ahead and let's change both sides of the equation. For this problem, it doesn't really matter if we do this, but I'm going to do it just to be consistent. And on the right-hand side, we get x. Now, to solve for y, what we want to do is we want to get rid of this denominator. So we're going to do that by multiplying both sides of the equation by 3y minus 4. So let's go ahead and let's do that. We have 2y plus 1 divided by 3y minus 4. We're going to multiply this by 3y minus 4. So that cancels. And then we got to remember on the right-hand side to also multiply by 3y minus 4. Now we can go ahead and cancel out these two terms. On the left then, we have a 2y plus 1. And on the right, we have an x times 3y minus 4. On the right-hand side, let's go ahead and let's multiply everything out. So our left stays the same, 2y plus 1. And our right-hand side is 3xy minus 4x. Now what we want to do is we want to bring all of our y terms to the left-hand side. So we'll move this term to the left. And then anything that doesn't involve y, which is this 1, we're going to move to the right. This gives us 2y minus 3xy is equal to minus 4x minus 1. Now we're going to factor out a y. I know this is hard, but hang with me. I know that you can do this. Success in math just comes from working really hard. Now we're almost there. All we have to do is isolate y. So we're just going to divide each side by 2 minus 3x. So this gives us y is equal to minus 4x minus 1, all divided by 2 minus 3x. Now, this answer is fine. However, notice that we have a negative here, a negative here, and a negative here. So 3 out of our 4 terms are negative. So I think it makes it nicer for an answer if we multiply both the top and bottom by negative 1. You don't have to do this. It just makes the answer look better. So this gives us y is equal to 4x plus 1, all divided by 3x minus 2. And then we can go to step 4, our final step. And that's just to rewrite y as f inverse of x. And this is equal to 4x plus 1, all divided by 3x minus 2. And that is our final answer. We did it. Now that you've seen these 4 examples, you'll be able to solve these types of problems on your own. In the next video in this series, I'll show you how to find the domain and range of an inverse function.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.